Okay, in this lesson, we're going to talk about radical expressions and exponent rules and kind of go back and forth between the different notations. And so, a quick review of the laws of exponents. Whenever you are multiplying two expressions with the same base, you add their exponents. And so, for example, if I had a to the third times a squared, that would give me a to the fifth. And so you can think of what this would look like expanded out. 3 copies of a times 2 more copies of a would give me a total of 5 copies of a. And when we're dividing, we're actually losing copies. So you subtract the exponents. And so an example would be a fifth divided by a to the third. That would give me a squared. You can imagine 5 copies of a being divided by 3 copies of a. And so 3 of the copies are going to cancel, leaving me with just 2 of the copies on top. If you have a product or a quotient inside the parentheses, you can distribute that exponent. And so if I had a times b cubed, that would give me a cubed and b cubed. If I had a divided by b cubed, I would have a cubed over b cubed. You have to be careful because if you have a plus or minus sign inside the parentheses, you cannot distribute that exponent. So do not distribute if there's a plus or minus sign. You would have to expand it out. Here, if you have 2 exponents on one base, you get to multiply them. And so if I had a cubed squared, that would be a to the 6. And so you don't want to confuse that with this example where we added the exponents. And so if you have the base written twice, it kind of leaves you room for a plus sign between the exponents, where if I don't have the base written twice, that kind of signifies to multiply. Anytime you see a negative exponent, I like to think of it as it's on the wrong side of the exponent of the fraction bar. So you just move it to the bottom of the fraction and change it to positive. And so to see why you do that, you could think of if I had a cubed divided by a to the fifth, if I use that subtraction rule, I would end up with a to the negative 2 power. And if I expanded it out, like we did in the previous example, you would see that 5 copies are on bottom and 3 copies are on top. And so that leaves us with more copies on bottom. We have 2 copies of a being multiplied on bottom. And so here, if you see a negative exponent, that just means those copies should have been on bottom. And likewise, if you see a negative exponent on top of a fraction, say there was like a b on bottom, you would move that a to the bottom and then make that 3 positive. Last few rules, anything to the 0 power is 1. And so it doesn't matter how many things. You could even have plus signs, multiple variables, numbers. If you raise it all to the 0 power, that whole ugly expression turns into a 1. And then a really important property is if you have a fraction exponent, it's actually talking about a radical. And so a very common example is the 1/2 exponent. That's the exact same as our typical square root. If you see a 1/3 power, that's the same as cube root. And then if you also have a number other than 1, say I had a to the 2/3 power, that 2 would stay in the exponent, but that 3 is still your cube root. And so I remember it by thinking roots are in the ground and powers are in the sky. So power is the top number and the root is the bottom number. And so just one more example, if I had, say, 8/7 as my exponent, that 7 is the root, the 8 is the power. And so I could rewrite that as the 7th root of a to the 8th. And you can actually put the 8 outside the root. Sometimes it's going to benefit you to take the root before the power, make the number smaller before you make it bigger. Okay, so these examples say rewrite each radical expression using exponents and each exponential expression using radicals. Evaluate if possible. So starting with the first one, we see 5 to the 1/2 power. That's the same as square root of 5. Here we see the 4th root of 25. So if we rewrite that as an exponent, the 4th root is the same as a 1/4 power. Here I see 27 being raised to a negative exponent. And so the first thing we're going to do is apply the negative exponent rule and move that to the bottom of the fraction so that we have a positive 1/3 exponent. And then a 1/3 exponent is the same as a cube root of 27. And a cube root just uncubes something. So the number cubed that would give you 27 is 3. And so this is the same as 1/3. That would be our simplified answer. These other examples, the 25 is not an even 4th power, and the square root of 5 is also as simple as that could get. This next example, 3 is the power, 4 is the root, and so we could rewrite this as the 4th root of 8 cubed, or you could do the 4th root inside the cube. This number doesn't turn out to be a nice number, so we'll leave it like that. Here, 5 is the root. It's the index of the radical. And so we know that's going to be the bottom of the fraction in the exponent. And so we can rewrite this as 10 to the 2/5 power. You really want to be careful and make sure the 10 is bigger than the 2/5, so it's clear that that's the exponent. We could also write that as 110 squared would give you 100 to the 5th power, the 1/5 power. And then here, 3 is the root, so our index of the radical is 3, and then 2 is the power. And so here it would be easier to write it as the cube root of 64 and then raise it to the 2nd power, because 64 squared is a really large number, and I don't know what the cube root of that is, but the cube root of 64 is 4. And then if we square it, it would be 16. Okay, and so eventually we're going to be solving equations with these rational exponents, and so we really want to be able to evaluate these numerical expressions without using a calculator. And so if you see 1/2 raised to the 1/3 power, we distribute that exponent to each, the numerator and the denominator. 1 cubed is just 1, 2 cubed is 8. So that would simplify to 1/8. -3 squared is -3 times itself, which is 9. Here, this negative is not being squared, and so you could add an invisible set of parentheses just around the 3. The negative stays outside. And so what this says is you need to square the 3, but keep that negative. And so this would end up giving us -9. You have to be very careful where the parentheses are. Anything to the 0 power is 1. 2 cubed, you could rewrite this as 2 to the 5th, but I think it's easier to do 2 cubed, which is 8, times 2 squared, which is 4, and that would give us 32. If you know that 2 to the 5th power is 32, it's the same thing. Here we can rewrite this as the 5th root of 32 and then cube it, because we just discovered that the 5th root of 32 is 2, and then we can cube it to get 8. The cube root of negative 125 is negative 5, because negative 5 cubed would give you negative 125. Here, we don't want to evaluate something with a negative exponent, and so if you see a negative exponent and there's already a fraction inside, you need to flip that fraction and then change the exponent to positive. It means reciprocal, so flip the fraction and change the exponent to positive. And then we can distribute that 1/2 power to both the numerator and the denominator. A 1/2 power is the same as a square root. And so this would simplify to 3 over 2. Okay, on this back page, we're doing some more simplifications with exponents. And so here I have the base written twice, so that means we need to add the exponents. And so that would give us x to the 11th. Here we're dividing, so we need to subtract the exponents. That would give us c to the 4th. Here we have two exponents on one base, so we need to multiply, so b to the 20th. Here we need to distribute this exponent to each term, including that coefficient of 3. So 3 gets an exponent of 3. X cubed already had an exponent, so those exponents end up getting multiplied. And so 3 cubed is 27, but 3 times 3 in the exponent would be x to the 9th. Don't multiply a base by its exponent. That is a very common mistake. Next, whenever you have parentheses, take care of those first. This first set of parentheses aren't serving any kind of purpose. It's just representing multiplication, so there's nothing to distribute. Here we need to distribute a 3 to each term. There's 3 places to distribute that 3. The coefficient, the a and b already had an exponent, so those get multiplied to a 12. And so that expression simplifies to 27a cubed b to the 12th. And then we can bring back the other expression, and you don't need the parentheses. And then our coefficients here are 2 and 27. Those aren't bases of any exponent, so you still multiply those as usual. And so 2 times 27 is 54. And then we have a cubed times a cubed. You add those to get a to the 6th. B squared times b to the 12th. You add those to get b to the 14th. And so your simplified answer would be 54, a to the 6th, b to the 14th. Here we need to distribute the 3. So I get x cubed over y cubed. And then I need to distribute this 4 to 3 places. The y already had an exponent, so that becomes an 8. X gets the 4, and z gets the 4. Now, when you're writing your expressions, only write one fraction to multiply the top and multiply the bottom. And you want to write each variable one time. So I have x cubed and x to the 4th. That would give me 7 copies of x being multiplied. And here we have y to the 8th over y to the cube, so we need to subtract those to get y to the 5th. And when you do that rule of subtraction, it's assuming you're writing it on top of the fraction. And then there was only one z term, and so that's just going to stay z to the 4th. Okay, last two, we have some negative exponents. Take care of the negatives at the end. Sometimes they resolve themselves along the way. And so first up, you have these coefficients here That says 6 divided by 2. You don't want to start subtracting coefficients. Those are coefficients, not exponents. And so 6 over 2 is still 3, as it usually is. And then x, we have x to the 1, and we're using our rule of subtraction here. And so it's going to be 1 minus negative 2. And then for the y's, we have negative 4 minus the 2. And so that simplifies to 3, and minus negative is the same as plus. So that would be x to the 3rd, y to the negative 6. And so now with that negative exponent, the y term is the only term that needs to move to the bottom of the fraction bar. Last example. Here we have a negative exponent in a fraction bar, so you can do that trick of flipping the fraction and then changing the exponent to positive. That way you don't have to distribute a negative exponent. And so then you can distribute that 2 to each term and then simplify 3 squared to 9. And so 9z to the 6y squared.